Namaste everyone. Hope all of you are well. Actually, till all the 9 lectures, whatever we have studied was the last topic was ionization constant of weak acids and weak bases because of the electrolytes, right? And in this topic, first of all, we are going to start with the relationship between the ionization constant of weak acid and weak base. So our main topic, relationship between Ka and Kb. Our today's topic is relationship between Ka and Kb. This Ka is ionization constant of weak acids or acids, and Kb is ionization constant of weak bases. First of all, I would like to inform you with some of the examples, like Ka and Kb represent the strength of an acid, and Kb is represent strength of the base, right? In case of conjugate acid base pair, they are related in a simple manner, so that if one is known, the another can be deduced. Just take an example, okay? Ammonium plus what? What will happen if we are taking an example? Ammonium NH4 plus in aqueous solution, okay, and water H2. What will be the reaction? Can you tell me? That will be NH3 and plus H3O plus. Is it right? Tell me yes or no. Definitely it will be right. So here, can you tell me what we can calculate? We can calculate the ionization constant of weak acids or acids. Ionization constant of it. So ionization constant of acid will be the concentration of products NH3 and H3O plus, right, upon concentration of reactants. You know very well the rate constant formula, the concentration of product upon concentration of reactant, right? So here the value will be, if you will calculate this value, right, means concentration of product upon concentration of reactant, the value is 5.6 into 10 to the power minus 10. 5.6 into 10 to the power minus 10. Got it? Now the same reaction for the weak bases, okay? Now we are taking NH3 plus H2 in the aqueous solution. So no need to worry. So what it will be? NH4 plus and plus OH minus, right? So what will be the formula of Kb? Concentration of product upon concentration of reactant, right? So what will be the value of this ionization constant of this weak basis? The value is 1.8 into 10 to the power minus 5. 1.8 into 10 to the power minus 5. Now tell me the main reaction, water plus water, H2O plus H2O, that is equal to H3O plus and OH minus, right? So here Kw is equal to H3O plus OH minus. And what will write here in the case of reactant? In the case of reactant, what will write? No need to write, because here the water and water is there. So since we are calculating the value, so that's why here you know very well, we just write 1.0 into 10 to the power minus 14 molarity. Now, as you know the formula, that what will be the relationship between the ionization constant of acids and ionization constant of base, where Ka represents the strength of ammonium plus and Kb represents the strength of ammonia. In this case, if you know, then it's very easy to understand. What is very easy to understand? That Kw is equal to Ka into Kb. This is the formula. So never forget the relationship between the ionization constant of acid and ionization constant of base. So as you have seen Ka into Kb, so the value and formula you can say 1.0 into 10 to the power minus 14 molarity is equal to 5.6 into 10 to the power minus 10 into 1.8 into 10 to the power minus 4. Can we write like this? Yes or no? Can we write or no? Definitely we can write, as you will see. And if you want to calculate the value, remember the formula. If you want to calculate the value, you should remember that the relationship between the ionization constant of acid and base will be Kw is equal to Ka into Kb. And if you want to calculate the ionization constant net, whatever the values are given, for example K1 into K2 into K3 dot till Kn. So whatever the values you want to calculate, it can be easily calculated by the formula K net is equal to K1 into K2 into K3 into dot till Kn. So remember the formula, this one, Kw is equal to Ka into Kb. That is the main thing which we should understand. As you have understand this formula, now I will tell you about that di and polybasic acids and di and polybasic bases. How you will understand this di, polybasic acids and polybasic base. See, as for example, just suppose H2SO4 is there. Here how many hydrogen will be liberated? You know very well. First of all, this reaction is HSO4 plus and H minus. Right? Sorry, I have done opposite. HSO4 minus and H plus. And in the case of second HSO4 minus, it will be again liberated as H plus and SO4 minus minus. So two hydrogen, when you will calculate this reaction, so H2SO4 is equal to 2H plus and SO4 minus minus. So how many hydrogen has been liberated, or how many hydrogen has been ionized, or it has been dissociated? According to that, you can calculate that it is a monobasic acid or dibasic acid or polybasic acid. So here if you will talk about, then this is dibasic acid. Why it is dibasic acids? You can see here, because two hydrogen will, if I talk about this H3PO4, tribasic acid, or you can say more than two, it is also known as polybasic. HCl is a monobasic acids. Similarly, in the case of, we talk about the mono, di and polybasic acids and acidic bases. The ionization reaction, for an example, just take, if I talk about H2X. So what will be the reaction of this H2X? First of all, H plus will be liberated and HX will be, this is a dibasic. What it is known as, the ionization reaction is, here the dibasic acid is H2X, dibasic acid. Similarly, if we talk about the bases also, you can write the number of OH like CaOH whole twice. So this is the diacidic basis, monobasic acids, dibasic acids, polybasic acids. Similarly, monoacidic bases, diacidic bases and polyacidic bases. It is not very hard, as you understand. It's very easy. The main thing which we have to understand is the factors affecting the acidic and basic strength. The strength of acid and bases, where we can calculate the pH of a given acid in a solution, and some acids should be stronger than others. The reason is that they make complex phenomena. If I talk about the strength and the polarity, just suppose if I talk about that, if I want to compare group 17th acids from hydrogen fluoride to hydrogen iodide, right? Means if I talk about the acidic strength now, then some group like periodic table HA bond strength is more important factor to determine the acidity than less in polar in nature. As the size increases down towards the group, the strength decreases. Size increases, strength decreases. So the acidic strength increases. For example, just suppose if I talk about in the group number 17, what are the group number 17 elements? hydrogen fluoride, hydrogen chloride, hydrogen bromide, and hydrogen iodide. So here the radius increases, means you can say here that the strength is increasing or decreasing, the size here increases, right? As the strength decrease, size increase, strength decrease, bond strength will be decreased, because you know very well, if I talk about the bond length of HF, it will be very short, HCl greater than HF, HBr greater than HCl, HR greater than HBr. So as the bond length increases, the strength will be decreased. So remember, dear students, that is the most important thing which we should remember is hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. The strongest acid is HCl and HF. It is approximately both are equal. Okay, approximately. I am not talking 100% sure that it both are, but little bit difference is there. So that's why I have written here approximately, and the rest of the things as we have studied also in the periodic properties chapter number 3. So according to that you can divide. And if you want to divide like electronegativity, right? Electronegativity. So as the electronegativity increases, the polarity becomes descending factors of the acidic strength. As the electronegativity increases, the strength of the acid also increases. Just suppose that methane, ammonia, water, HF. Methane, CH3, ammonia, CH4, sorry, methane, CH4, not CH3, methyl. Methane, ammonia, water, HF. If I talk about this four, then the strength of the acid will be like this. Hydrogen fluoride will have the greater strength. So no need to worry if I talk about that how the factors affecting the strength of acid and strength of bases. Common ion effect in the ionization acids and ionization bases. Common ion effect. What is common ion effect? If anybody will ask you, just take that acetic acid. Okay. If I am taking acetic acid, just take acetic acid CH3COOH, right? This acetic acid will be dissociated as H plus and CH3COO minus. Acetate ion and hydrogen ion, right? It will be dissociated. So here if we will calculate the ionization constant, then what will be the value of ionization constant? Can you tell me? Ka is equal to hydrogen concentration ion, acetate concentration ion upon acetic acid concentration, right? Can we write like this? Yes or no? Because we know very well the ionization constant is the concentration of product upon concentration of reactant. So the addition of these acetate ions to acetic acid solution result in decreasing the concentration of hydrogen ion. Means as we will dissociate, the hydrogen ion will be liberated or hydrogen ion will be dissociated. So hydrogen ions are added from the external source. Then the equilibrium moves in the direction of undissociated acetic acid. In a direction of reducing the concentration of hydrogen ion like H plus, this phenomenon is an example of common ion effect. It can be defined as the shift in equilibrium on adding a substance that provides more of an ionic species already present in the dissociation equilibrium. So dear student, if we talk about these all the things, it is very important to notice about this common ion effect. See, common ion effect is not a, it is a phenomenon. Phenomenon means, as you can see here, the first hydrogen ion has been liberated or it has been dissociated. As it has been dissociated, so the acidic strength will be decreased. The number of hydrogen ion gives a better concept about that the strength of acid. So here, as you can see in the acetic acid only, that hydrogen ion has been liberated. as the hydrogen ion has been liberated, or you can say it has been dissociated. So this phenomenon is a common ion effect, because here it has changed into the ion. It can be defined as the shift in equilibrium on adding a substance that provides more of an ionic species already present in the dissociation equilibrium. Thus we can say the common ion effect is a phenomenon which is based on the Le-Chatterley's principle. You know, we have discussed the Le-Chatterley's principle. I hope the changes of chemical equilibrium, concentration, pressure and temperature, if you have remembered, then it's Le-Chatterley's principle. Now the pH of the solution resulting the addition of this acetate ion. Now how you will calculate this acetate ion's pH? Just suppose the initial concentration of this acetic acid is 0.05 molarity. Just suppose I am telling you, okay? So what will be the value? If you know the value, if you know this value, then it's very well. See, no need to worry. CH3COOH has been dissociated as CH3 COO minus and H plus. Okay. At the starting initial concentration, it was 0.05. They both were 0. Now they became X. So this will become 0.05 minus X. Right? And if you want to calculate the concentration, Ka is equal to the concentration of products upon the concentration of reactant. Can we write like this? Yes or no? Definitely we can write. But here the most important thing, that if we talk about the equilibrium concentration, then in the equilibrium concentration, here this will be 0.05 minus X, here it will be X, and here it will be X plus 0.05. So this is in the case of equilibrium. You can see, as I have underlined, in the equilibrium concentration we can write like this. So no need to worry, dear students, it is a very small gap for weak acids, so that's why here we can write it very easily. Now hydrolysis of salt and the pH of their solutions. Hydrolysis, you know, what is the meaning of hydrolysis? Salt formed by the reaction between acid and bases in the definite proportion, it undergoes ionization in water. You know very well. So here only two topics are left: hydrolysis of salt and the pH of the solution, and buffer solution. So we will not take more video. I'll just complete in this only. So it's very easy to understand. Let's make you understand about the hydrolysis of salt and the pH of their solution. So our topic is hydrolysis of salts and pH of their solution. Can you tell me how salt is formed? Salt is formed by acid plus base is equal to salt plus water. Fundamental reaction of acid and base. There are four types of salts also, as you know very well: acidic salt, basic salt, neutral salt, and amphoteric salt. Right? Acidic salt, strong acid plus weak base. Basic salt, weak acid plus strong base. Neutral salt, strong acid plus strong base. And amphoteric salt, weak acid plus weak base. So as you know about these reactions, as the salt is formed, when these salts ionize in the water, what will happen? They will break down into cation and anions, right? As they form ionization and exist as a hydrated ion in the aqueous solution or interact with the water to form corresponding acid and bases, it's depending upon the nature of the salt. The later process of interaction between the water and cation and anion of both the salt is called hydrolysis. As for example, let's suppose here some of the salts like you can say NaCl, Na2SO4, CaSO4, any other salt. When these salts undergo into the water, they dissociate at Na plus and Cl minus, 2Na plus and SO4 2 minus, Ca2 plus and SO4 2 minus. Means as they undergo into the water, as we do hydrolysis of this water, so they dissociate into cations and anions, and afterwards, the later on, the process or interaction of these ions between the water and cation and anions, both the salt is called hydrolysis. Now if I talk about the pH of the solution get affected by this interaction, the cations of the strong bases and the anions of the strong acid simply get hydrated but do not hydrolyze. Therefore the solution of the salt formed from the strong acid and bases are neutral. Their pH is 7. However, other category of the salt do undergo hydrolysis. My dear students, to understand, in the neutral salt, since both are the strong acid and strong bases, so in the strong acid and strong bases, what happens? They undergo as they first of all convert into the ions, and then again they mix with the water, and cation and anion is again situated, the sodium chloride is formed, again they are dissociated. So these are the hydrolysis of water. But in the case of the other acids like acidic acids, acidic salt, basic salt, amphoteric salt, so that time what happens, the first salt of weak acid and strong base get completely ionized in aqueous solution and then undergoes hydrolysis in water to give the cations and anions. Similarly, if we talk about the basic salts, neutral salts, not neutral salt, except neutral salt, the same process goes under here. Now we are moving towards the buffer solution. Now can you tell me what is buffer solution? Very, very important topic of this chapter, buffer solution. Very, very important. If you have ever heard this word, then also it's very easy to understand. The solution which resists change in pH on dilution or with the addition of small amount of acid or alkali are called buffer solution. Just suppose any solution is there, and if we mix the small amount of acid or small amount of bases and the pH starts changing, so that type of solution is called buffer solution. Whatever the solution is given, either acidic solution, basic solution, and we have mixed in the small amount of acid or base, and the nature of the pH has been changing of the solution is called buffer solution. Yes, many things have their definite pH values like our body's blood, which control our full body biochemical process. It is the, and if you use any cosmetic formulas or cosmetic creams, that time also they are at the fixed pH value, they are packed with the fixed pH value. Now in the buffer solution, pH can be prepared from knowledge of the ionization constant of pH weak acids and ionization constant of pH bases, it can be controlling by the ratio of the salt and the acid of the salt and the bases. The mixture of acetic acid and the sodium acetate act as a buffer solution. Acetic acid and sodium acetate. Just suppose acetic acid CH3COH, sodium acetate NaCH3COON, you can write like this, CH3COON, sodium acetate. What will happen? Can you tell me? This was also at the initially acetic acid only, but as in the salt it has been changed in the sodium acetate, and this is acetic acid. When you will mix this both, the mixture of this acid and this acetate, it will act as a buffer solution whose pH value will be around 4.75. Means it is acidic only, but it will be around 4.75. So here this solution will be called as a buffer solution, and a mixture of ammonium chloride and ammonium hydroxide. Ammonium chloride and ammonium hydroxide. It will be also acting as a buffer solution, and whose pH value will be around 9.25. Now how you will design the buffer solution? If you know the ionization constant of acids and ionization constant base and the pH values, the equilibrium constant, which will help you to prepare the buffer solution that you can know by the pH. Just suppose we are going to prepare a acidic buffer, and similarly we are going to prepare a basic buffer. How you will understand this acidic buffer and basic buffer? So here you can see that means here if you want to prepare that will be different, but in the higher classes we will study more about it. But here, as I have told you, in the acid we have mixed a small amount of acid, and that solution will be varying the pH value of that solution. As they vary the pH value, then that type of solution will be known as buffer solution. Similarly, you can see here ammonium chloride, ammonium hydroxide. Both are the product of ammonium only. One is salt and another is hydroxide base. As you will see, there is a change in the pH value. As there is a change in the pH value, means you should remember that this solution is buffer solution. And if you want to prepare like acidic buffer, then you should know the acidic pH. Generally we use weak acid and its salt to form a strong base. Weak acid and its salt to form a strong base. We develop the equation relating the pH and the equilibrium constant Ka of weak acid and the ratio of concentration of weak acid and its conjugate base. For general case, we understand that weak acid or hard acid which ionize in water. Just suppose that HA is a weak acid. As well, what happened? HA is a weak acid. Just suppose. Okay, this is a weak acid. HA is a weak acid. When we mix into the water, as they dissociate H plus ion, it will convert into H3O plus and A minus. Is it right? Yes or no? The reaction is right or not? Yes. So can you tell me what will be the ionization constant or Ka value? It's very easy to make here, you know very well. Ka value will be the concentration of product H3O plus and A minus, right, upon HA. Means concentration of product upon concentration of reactant. You can see here as I have written also on the board. So it's very easy to understand. And if you want to rearrange this expression, means if you want to calculate the hydronium ion value, means this H3O plus value, what will be the value of H3O plus here? H3O plus will be equal to Ka into HA upon A minus. Am I right? Yes or no? Just we have done rearrange the values for the expression. Now taking logarithm both the sides. Now you have to take logarithm. Why we are going to take logarithm? Because we have to calculate the pH values, right? So as we take logarithm both the sides, so what will be the value, can you know? pKa is equal to pH minus log A upon log H. Means, dear student, it's very easy to make you understand that here Ka will be the pH. Now just let me erase this board, then you will be able to understand properly. Just suppose here the reaction is, the ionization constant Ka is equal to H3O plus, this is the pH, and A minus upon H, right? Here we are taking logarithm both the sides. As we take logarithm both the side, left side and right side, the value will be, first of all, how we'll take logarithm? We'll take as in the form of pH. So the value of pKa, this will be pKa is equal to, here H3O plus is there, so this H3O plus will be converted, log A upon log B is equal to log A minus log B, right? Log A minus, so this will be H3O plus will be converted as pH. This H3 will be, because in the hydrogen ion concentration, minus log A minus upon H, right? Got it or not? We have just arranged in the form of logarithm both the sides, and if you do not understand, then I am just giving you a hint that the pH is equal to pKa plus log conjugate base upon acid, conjugate base upon A. So this pH is equal to pKa plus log conjugate base. This A minus is conjugate base, that is A minus upon acid, that is Ha. Understand? So in this way, after taking, as you know very well, this expression is known as Henderson-Hasselbalch equation. Henderson-Hasselbalch equation. Henderson-Hasselbalch equation. This equation will be known as Henderson-Hasselbalch equation. As you have seen that we have understood about this equation, the quantity of this conjugate base and acid ratio, the concentration of this conjugate base of the acid and the acid present in the mixture, since acid is weak acid, it will ionize to a very little extent, and the concentration of this Ha, means acid, is negligible different from the concentration of acid taken from the buffer solution. So also the most of the conjugate base A minus comes from the ionization of salt of the acid, therefore the concentration of conjugate base will be negligible, differ from the concentration of salt. So you can write here that in the form of pH is equal to pKa plus log, this will be in the form of salt and this will be formed in the acid. Got it? So this is our equation. In this equation, the concentration of A minus is equal to the concentration of Ha, then the pH will be equal to pK, because the value of log 1 is 0. Always remember the value of log 1 will be 0. I hope all of you understand. Similarly, if you want to calculate for the pOH, then what will be the value? pOH, as pH we have calculated, so no need to worry, dear student. Instead of Ka, it will be Kb, and conjugate base was there, here conjugate acid will be there, and upon base will be there, right? So no need to understand as here. Here as pH, so here you can write pOH is equal to pKb plus log conjugate acid that is Hb plus upon base. Got it? So here as you can see the formula, not Hb, sorry, only B, right? So here POH is equal to pKb plus log conjugate acid upon base. So pH of the buffer solution can be calculated by using this equation. pH plus POH is equal to 14. This is the most important formula of this whole chapter only, you can say. This formula you should never forget in your life, because this thing we have started from class 10 only, right? So here as you know this formula, according to this formula, pKa plus pKb is equal to pKw. On putting this value, it will be just form pKw minus pH is equal to pKw minus pKa plus log conjugate acid BH plus upon base B, or pH is equal to Ka plus log conjugate acid BH plus upon base B. So remember dear students, as the buffer solution, therefore a buffer of pH close 9.25 can be obtained by taking ammonium solution and ammonium chloride solution on the same molar concentration for the buffer solution formed by ammonium chloride and ammonium hydroxide. So very easy, pH is equal to, what you will do, instead that pH, it will be, we can be write as a pH is equal to 9.25 plus log 9.25, here POH, in that case pH is equal to 9.25 plus log conjugate acid upon base, right? So as this you can understand, it's very easy. Now as you understand the last topic, last or second last you can say, it will be also known as the solubility equilibria of sparingly soluble salt. I hope that, let us discuss one more thing in this next video. We'll take one more. So total 11 lectures will be there in this chapter. As already I had informed you that from lecture 1 to lecture 10, how to go ahead. Just remember whatever you are doing, make step by step, first lecture, second lecture, third lecture. Remember those things, that what things we have studied, and according to that, just try to make the concept clear. Whatever the numericals you are having, try to solve those numerical. Whatever the basic concepts you are having, try to solve through the basic concepts. And after then, if you are not getting numerical, just turn your exercise and start solving NCERT exercise. The questions which are given internal, try to solve those questions. And slowly you will know that how to solve it. See, we were not doing anything in the equilibrium, and as we have came to know that what is equilibrium, it is Le-Chatterjee principle, what will be the effect of change of concentration, what will be the effect of change of pressure, what will be the effect of change of temperature. After then we will move towards the physical states, and then slowly we have came till the buffer solution. No one was knowing about this buffer solution. We are just knowing about the solution. We were not aware about this buffer solution. But as we move ahead one by one step, so we'll know, first of all we have to make a note, we have to clear the concept. See, writing a note will give you the better concept. That's why each and every teacher prescribes you to make a note of that subject. As you make the notes of that subject, it will be very easy for you. Whenever you will turn the pages, everything will be just revolving in your mind that yeah, this thing we have studied at that time. So it will be easy to revise the whole chapter within a few minutes. I hope all of you have understand. That's all for today. Thank you very much. If you are not making notes, then it will be a very big mistake. So don't forget to make notes. If you have not made yet, then start making, because you can make notes within 1 or 2 days. I know that if you are not seeing all the videos till this, all the lectures, and you can see this lectures video also, you can make the notes by seeing the lectures also. That's all for today. Thank you very much. Don't forget to like and subscribe the channel. If you have not liked and subscribed, please like and subscribe. Share this video with your friends so they can be also benefited. Thank you very much.